Alright, now let's talk about addition. Let's talk about multiplication or general multiplication in matrices. I need you to pay very close attention, especially to this one, general multiplication of matrices. Let's get into it. Suppose you have two matrices here. These two matrices are multiplying. Why? Because we do not have any sign in between them. In addition subtraction, we're presented with an addition sign or subtraction sign. But this is now general multiplication. When it comes to general multiplication, we do not multiply corresponding values to say A times E, B times F. Instead, we are going to use row by column method. By row by column, we mean we are expecting answers of this format, a 2 by 2. The first matrix will be supplying rows. There's no way we are going to look at A and C, but A, B, C, D. The first matrix will give us rows, then the other matrix will give us columns. We'll be looking at EG, not EF, but EG and FH. That's row by column multiplication. Right. These first two answers of the first row, you'll be using the first row AB. The multiplication movement is like this. To get the first two answers of the first row, we are using this first row. First row will be multiplied by both columns in such a movement. In this row, we have a firstborn and a secondborn. In this column, we have a firstborn and a secondborn. So first and first will multiply, that is A times B, first and first, then the last and last, but we'll be adding here firstborn times firstborn plus last and last, that is B times G. That's row by column, first by first, last by last. On the other side, we are still on the first row, not the second. As long as you're on the first row, you use the first row of the matrix. So again, AB is multiplied by FH. Firstborn A is multiplied by firstborn F plus the lastborn B and the lastborn H. That way. How about these two? Is now the other second row, so we are using the second row CD, but still we are multiplying by these columns. So that's C times E plus D times G. That's row by column. Again, this row is going to multiply by the other column. Firstborn C and firstborn F plus D times H. That's row by column multiplication, general multiplication. So we are going to talk more detailed methods as we are using examples involving real numbers. Example number 1, you are asked to evaluate or simplify 3, 2, 1, 4, 0, 5, 8, 6. Alright, I'm going to multiply these two matrices using row by column method. So you can aid or guide yourself through using these arrows. The first matrix will give us rows, then the other matrix will give us columns. Then you sketch the other, the 2 by 2 matrix. In the first row, I'm using the first row. That is 3 will multiply by 0. It's a movement like this. 3 by 0 plus 2 by 8. I moved a row by a column. On the other side, I'm still using this row, but the other column. 3 times 5 plus 2 times 6. Then, second, now we are using the other second row, so we're using this row, that is 1 by 0 plus 4 by 8. That's row by column. Second row, first column. Then last one, I'm using second row in the other column. 1 times 5 plus 4 times 6. Alright, that way. So now, let's proceed to simplify multiplication first. 3 times 0 plus 0 plus 2 times 8, 16. 3 times 5, 15 plus 2 times 6, 12. 1 times 0, 0 plus 4 times 8, 32. 1 times 5, 5 plus 4 times 6, 24. By the way, we forgot to cross-check. Always follow up your working before you proceed. This is supposed to be row by column. 3 by 0, confirmed. 2 by 8, confirmed. The other one, 3 by 5, confirmed. 2 by 6, confirmed. 1 by 0, 4 by 8, 1 by 5, and 4 by 6. Correct. Now, multiplication, 3 times 0 is 0, 2 times 8 is 16, 3 times 5 is 15, 2 times 6 is 12, 1 times 0 is 0, 4 times 8 is 32, 1 times 5 is 5, 4 times 6, 24. Then we will proceed to get our very correct answer. 16, 15 plus 12, we'll get 7, 2, that's 27. And 32, then that one get 29. That's general multiplication of matrices. But now they come in different forms and shapes. Since we talked about different arrangements of matrices. For instance, if this one 3, 2 minus 1 minus 4, or let's say a negative in and a 0 and 8. These matrices are of different orders. So before you start multiplying, we advise you that you need to name or state the orders of these matrices first. Starting with the first matrix, what is the order of this matrix? You count the rows. 1, 2. It's a 2 by how many columns? 1, 2. The first one is a 2 by 2 matrix. How about the other one? Let's count the rows. 1, 2. How many columns? 1. This is a 2 by 2 matrix, and this one is a 2 by 1 matrix. Why we need to do this? We do this for two very important reasons. The first thing, we need to check if it is possible. Always when you state the orders of matrices, median values must be equal. If these values become different, then it simply tells you that it is impossible to multiply. So your final answer, you'll be writing down, it is impossible to multiply. So you always check before you multiply, check if the multiplication is possible. How do you confirm that it's possible? Mid values must be equal. Number of columns of the first matrix should be equal to number of rows of the second matrix. Then lastly, for this one, confirm that will be possible. Then the other reason is the first digit and the last digit will tell us the structure of the answer. We are going to get a 2 by 1 answer. We are going to get a 2 by 1 answer. This is the order of the answer. So we are going to sketch this answer 2 by 1. 2 by 1 is just like this one. One number on top, one number below. So it's very important to state the orders of matrices for these two important reasons. Now we are multiplying row by column. The first row is 3 multiplied by 0 plus minus 2 multiplied by 8. Check, we do not have the other column because we do not have another column here, so simply row by column plus already this told us to only have one digit on top. Vomiters, you multiply first before you add, that's why it's important to include brackets. Let me confirm, 3 times 0 minus 2 times 8, correct. Then the last one, I'm using the second row because the answer is on the second row. Minus 1 times 0 plus 4 times 8. Confirmation, minus 1 times 0, 4 times 8. Correct. Then I'll proceed to multiply. 3 times 0, 0 plus minus 2 times 8 minus 16 minus 1 times 0, 0 plus 4 times 8, 32. And the final answer is 0 times 0 plus minus 16 plus minus 16, 0 plus 32, you get 32. So it's important now because these matrices come in different orders. So you must state their orders to check if it is possible to multiply. Let me enter 1.7. Let's say you are asking to multiply matrices of this arrangement. First thing, state the orders. How many rows? 1. By how many columns? 2. The other one, how many rows? 1, 2. By columns? 1. So these mid values are equal, confirming that it is possible for us to multiply. So it's possible multiplication. How about the answer? The answer is going to be a 1 by 1 matrix. So let's present the 1 by 1 matrix. It's row by column. 1 by 1 simply means that we are going to have just one number in the brackets. So it's 3 multiplied by 5 plus minus 2 multiplied by 1. That is 3 times 5, 15 plus 2 times minus 1 is minus 2. And the final answer is 15 minus 2, you get 30. This is the 1 by 1 answer we're talking about. So it's important to check the order of the answer before you multiply. Lastly, let's say we have this matrix 3, 4 and 7, 0. Orders first, 1, 2 by 1. Then this one, 1 row by 1, 2 columns. Again, it is possible. But interesting, look at the answer. The answer is going to be 2 by 2. 2 by 2 matrices are like this. The 4 numbers, so that 2 rows and 2 columns. And look at this stubborn mathematics. A row by column. By column. We only have one number in the row and one number in the column. So there's no addition there, it's just 3 times 7. Then on the other side, the row by column. Why we are not adding both, do not have the second values in the row and the column. So it's 3 by 0. And here we have 4 by 7. Then 4 by 0. That's a step on multiplication. Now it's 3 times 7, 28, 21. 3 times 0, 0, 4 times 7, 28, 4 times 0, 0. Let me check. Row by column, 3 times 7, 21, 3 times 0, 0, 4 times 7, 28, 4 times 0, 0. That's general multiplication. So in exam situations, they use letters. They use letters like this. Given that A equals 4, 2, 3 minus 1, B equals minus 1, 6 minus 2, 8, C equals X, 3, 2, maybe 2X. Then they say evaluate number A, AB, B squared, AC in terms of X. By AB we mean you are going to multiply matrix of A and matrix of B. And it's very important. AB is not equal to BA. If you say A, B, make sure you start with matrix A followed by matrix B. If you do the other way, you will not get a correct answer like this. A, B means you start with the matrix A, 4, 2, 3, minus 1, multiplying it by B, which is minus 1, 6, minus 2, 8. Then you do the row by column, rows and columns, then you multiply. I wanted to illustrate this one, B squared. By B squared, we do not mean that just give power 2 to these values. It means matrix B multiplied by another B. So you write them both, minus 1, 6, minus 2, 8. Then again, minus 1, 6, minus 2, 8. Then you do row by column multiplication, row by column multiplication to get the answer. How about the last one, which is written in terms of x? Find AC in terms of x. AC equals, take matrix A, 4, 2, 3, minus 1, then take C, x, 3, 2, and 2x. The statement written in terms of x simply means do not bother, don't worry about the value of x. Just use the letter x in such a manner you wanted to use a number positioned here. So we are simply using the letter x. Row by column multiplication, I'll do this one quickly in a shortcut way. 4 times x plus 4x plus 2 times 2 plus 4, that's row by column. Then 4 times 3, that's 12 plus 2 times 2x plus 4x. Then 3 times x, 3x plus minus 1 times 2 plus minus 2. Then 3 times 3, 9 plus minus 1 times 2x minus 2x. We are multiplying, we are solving in terms of x. Lastly, these are like terms, so they will then 4x plus 4. This one, again, unlike, so it's 12 plus 4x, just like that. This one, plus and minus, become negative. It's 3x minus 2, and that one is 9 minus 2x. That's multiplication in terms of x. Check again another tutorial on inverse determinant of a matrix as well as special matrices. Mr. Executive, kaboom.